All right, this is the video for the last page of the Unit 6 review, this table where we're filling in, identifying the type of function, where the vertex or center is, if there are asymptotes, where they are, and then the domain and range. And this is all algebraically. This is by hand without technology. Okay, so there is the answer bank on the back side here. This one is updated, the one that I posted on It's Learning. The one that is printed in the original review that I handed out had some errors that we came across, and I fixed those and I took out the extra answers. So this answer bank here has only the correct answers. There's nothing extra, nothing will be left. And those mistakes, typos were corrected. All right, so we're going to start. I'm actually going to go through and we're just going to go ahead and fill in this entire column, type of function. You've got to know, looking at an equation, what type of function it is. So I'm actually just going to type that rather than writing. Let me get it in color also. So we'll put this in blue. Okay, so the type of function. When x is in the exponent, this is exponential. Okay, x is not in the exponent. There is an exponent of 2. That's the highest degree here. So that is quadratic. And then, oh, I thought that would make all my stuff blue. Maybe not. I'll just change them all at the end. Okay, now when x is in the denominator, we have rational. Okay, x is under a radical, and it's the cube root radical. Third root, so cube root. X is in the exponent again, so exponential. Okay, x is raised to the third power, that's the cube function. X is in the denominator, so again, that's rational. Log, hopefully y'all can identify logs. They have the word log in them. All right, under a cube root again. X is under a square root. Now this one, remember, it could be listed as square root. Radical means the same thing. So the radical function and the square root function. Here x is in absolute value bars. So this is an absolute value function. Okay, again, the highest degree is squared, so this is a quadratic. And then this one is the cubic, another log, and another square root. Or radical. Make all of those blue, and then we'll move on. Okay, so being able to identify what the parent function is, what type of function your equation is, that's important. Now, vertex or center. Of all of these different types, so there's 8 different ones listed here. There were 9 that included linear though, and we're not practicing with linear. I think everybody's mastered linear functions back in algebra. So, but of these 8 functions, just a quick, I'm going to pull up our completed notes on that reference sheet that we did. Well, if I can find it, I'm going to pull it up for you. No, that's not the one I want. I want the one that they just a single page, front and back. Well, oh, here. Here we go. Okay, so you should have a copy of this with all of the important things to remember filled out, but I just want to give you the general shape of the graphs again, okay? Because when we start talking about a vertex or a center, I want you to understand what that's asking for. Okay, so absolute value and quadratic, both of these have a change in direction. So there is a vertex, that point where the graph changes from decreasing to increasing. Okay, that is your vertex. Okay, so absolute value and quadratic both have a vertex. Square root, technically, I guess it's not a vertex because we're only looking at half of this parabola on its side. If you add the negative square root, that would be the reflection of this down here in quadrant 4. This would be considered the vertex, but we're going to go ahead and just, for the sake of finding this point, because we need that point to give our domain and range, we're going to find that. We'll call it the vertex. And then for a cube and cube root function, there's not a vertex. There's no change in direction. This graph is always increasing. There is a point of inflection here at the origin of the parent function where the graph changes concavity, like it, whether it's concave in, concave out, like that little S shape here, or same thing here, that little S shape for the cube root. So that point of inflection is what we're going to find, or that's like the center of that graph. Okay, so that's what we're going to find for the cube and cube root. Now, exponential and log, these both have asymptotes. Remember, the exponential has a horizontal asymptote here. The graph is coming here and then exponentially increases that way. Log is the inverse of that. It has a vertical asymptote here. So this is coming up along that asymptote and shooting out to the right there. So these graphs have no vertex or center. They don't change direction either. There's no point of inflection. So we're not going to list anything for those. So that's why for the logs and exponentials here, I went ahead and put in the NA, not applicable for vertex or center, because there's not a point for you to find for those that we need. That's going to affect the domain or range or anything. And then rational has both a vertical asymptote and a horizontal asymptote. And there's the curve on, there's multiple curves there. Now, I do want you to find the center, but it's not actually a point on the function. That point that we're going to find, that we're going to call the center, is actually the point where the asymptotes intersect. So where that, for the parent function, that's at the origin, 0, 0. Okay, so that's what we mean when we say vertex or center. That's what we're looking for. And for those columns that say asymptotes, just know these are the only 3 with asymptotes. Rational has both, log has vertical, exponential has horizontal. So we could go ahead and put a bunch of NAs here for asymptotes under, so I'm just going to copy this. Okay, quadratic has neither. Rational is going to have both. Exponential is only going to have horizontal. Cube root won't have either. Exponential will only have the horizontal, which is this column. So this one's not applicable. Cubic has neither. Rational has both. Log only has vertical. Cube none. Square root has none. Absolute value none. Quadratic none. Cubic none. And square root radical none. And again, the log only has the vertical. So if you come down here, that's why all these NAs are on this answer bank, because there was a lot of not applicables for asymptotes and some of the vertex centers that I had already filled in for you. Okay, so now we're going to go through and look for, actually, I'm going to stop this video here because I'm about to have to go pick up my kids. I don't want to run late. So that'll be the first half of this video. So that is identifying the type of function, whether or not it will have an asymptote, and what kind of vertex or center, what point we're looking for. And so I'll make a second video here in a little bit that will go over actually finding the ordered pair of this point for this column, and then using that point to determine where's the asymptote, if there is one, and what's the domain and range.